Okay, you guys ready? Class?
Yes.
All right, so I know you guys are all super excited about having an actual textbook right now in your hands. Now we're going to go over, so limits and continuity. This is a big thing that we missed out on. And the new textbook didn't have enough of it, so I am going back over it. So again, what that thing that was done on Wednesday, we're not going to talk about it. Okay? Good. All right, so let's go through here. Basic limits. Okay, so limit of a constant. So if there is a function that is like the limit, so y equal, let's not do a y equals. Let's say it is going to be, yeah, f of x equals 2. A constant, that means if I plug in any value, there is no variable, right? If there is no variable to plug in, then it doesn't vary. No variable doesn't vary. What does the word variable mean? Kind of. It changes. It varies.
Okay.
So a constant doesn't have a variable. So therefore, it is always that. It is always that. So that's what this is actually saying. So constant, no variable, it is going to be, so if I take the limit of f of x in here, my answer is going to be 2 because it's not going to change. There's nothing to plug in. That's what that means. The limit of the identity function, okay, so if it is f of x equals x, if I was going to take the limit of an identity function, that means the limit is the number I plug in. So I only have one variable, and I'm only plugging in the limit as x approaches c. So I'm going to replace x with c, right?
Okay.
I'm going to replace x with c. So this one, it would basically turn into f of c is c. Because you are finding as x approaches c, it's just going to be that. It is that number. So nothing too crazy on that. Now, does that make better sense? Good. No nonsense? Okay, good. Find the limit of a sum, difference, and product. Now, the word sum refers to as what? Come on now. What's a sum? Addition, right? Adding things together. So if I had the sum of two limits, I would take their limits first, find the limits of both of them, then add those together. That's what a sum. Okay, same thing if it's going to be a difference or a product. Difference is a subtraction, right? It's a subtraction or minus sign. So I would find the limit first and then subtract those two. And then product would mean same thing. I'm going to take the limit first and then multiply the answers together at the end. Equals sum of the limits. There we go. All right. Difference of the limits right here. We already did that one. Okay. Find the limit of some different. Okay, so limits of product. There it is. The third one. Find the limit of a product. Now, for these ones, what would I do? So these ones actually don't have any holes. There is no domain restrictions. Okay, domain restrictions are places in which that the problem will be undefined. I'm not going to have any undefined places because all these are basic functions. Nothing crazy. So if I plug in 3 right here, as x approaches 3, it's going to be basically just the limit as x approaches 3 squared, which is 9.
Well, my code is not working to get new students logged into class, and the other one doesn't have a code.
Yeah. Give me a minute. Okay. All right. So, going with this one here. limit as x approaches -5, do the same thing, same basic thing. So for this one, it would be -4, right?
Yes.
Times -5, because I'm just plugging in my value and I don't have any restrictions, so it's going to be a positive 20. Basic, right? Plug it in, evaluate. Now, here's another one. So this one right here also doesn't look like there's any restrictions. Now, for this one, this first one here, can I plug in 1? Yeah, let's see. So 2 times 1 times quantity of 1. I like, when I plug in, I like plugging in using parentheses. It makes my life easier, because I could always see what was plugged in there or in replacement of the x's. So 2 times 1 is 2, right? So that's 2. And then 4 plus 1 is 5, which gives me 10. All right? Now, this one says 2 to the right. Now, this one right here is not going to be a problem because there is no restrictions here. There is no restrictions. So if I plug in 2, it's going to be, let's see, 4 times 2 times quantity 2 minus 2. 2 minus 2, that is approaching what number? Even if it is going to be from the right-hand side. 2 minus 2 is 0. So I know that from the right-hand side, that number is going to be approaching 0. Anything times 0 is?
0.
Thank you. So no matter what I had over here on the outside here, it's going to be 0. Because anything times 0 is 0. There we go. Find a limit for a piecewise defined function. Now, if the limit exists, it must be continuous. Now, for it to be continuous, it must be continuous at all points. This, you check every single point. Okay? Do I have any restrictions on my domain? What that means is, am I given a domain from start to finish?
Yes.
Am I given one?
X's.
No, I'm not. Does it give me a start? Say no.
No.
Because it just says less than 2, right? So there's no starting point, because if it looks like that, it would be like from 0 to 5 or something like that. It would be giving you a domain, or over the interval of. Those are the words that you're going to be looking for. Over the interval of, or in the domain of. So we check endpoints. That would be your first thing that you would do. Okay? It's almost like that's so important. You might want to write that down. You would have to check the endpoints if you are given an interval. If it is not continuous over that interval, then I might have some issues. And that's what you have to start checking for, especially for continuity here. So what we're going to do here, we're going to check to see. So as x approaches 2, because I'm going to find the limit as this one. So now let's see, what's going to happen as I plug in 2 to this first problem? 3 times 2 is 6, plus 1 is 7. So this one, as I'm doing right here, so this one's going to give me 7. And what about this side right here? I'm going to do the same thing over there. So if the limit exists and these are continuous, the left side, which is less than 2, has to be equal to, it has to go to the same point as the right side. And my right side here, I'm finding out, is going to be 2 times 2, parentheses, 2 minus 1. So 2 minus 1 is 1, right? And then this is going to give me 2 times 2 is 4, which gives me a grand total of 4. So I just tested for the rules of a limit to work. The left side has to be equal to the right side. Left side has to be equal to the right side. The left side is equal to what number? 7. The right side is equal to?
4.
Are these continuous?
No.
No, because the left side does not go to the right side. So that means that is going to be a jump. That's going to, or technically a fall, but still, it is, remember, as a roller coaster, it would look like this. So 3, so it would be going up like this, and then this is a hole there, and if this is my graph, this would be at 7 right here, and the next one picks up at 4. So let's call this one right here. And that would be a solid dot, and my slope is positive. Yeah, slope should be positive. Slope should be positive going up like that. So that's going to be an example of a jump. So the left side does not equal the right side, and I found that mathematically, algebraically, by plugging in my numbers and where there could be a discontinuity. Limits of a power and the limit of a root. Okay. If the limit of the function exists and n is a positive integer, then it's basically whatever the limit of the function raised to that power is same as just plugging that in. It's equal to the limit of whatever it is. So it's basically whatever your function raised to that limit, or raised not to the limit, to that exponent. I don't know why I can't talk today. Anyway, it is just going to be the same thing as multiplying the whole thing or raising the whole thing to that exponent. Now, for this one right here, if the limit exists of a root, now, for the root to exist, it has to be greater than 2, and n is going to be important. Because if it is an even number, I cannot have a negative inside there. A second root, which is just regular square root, you cannot have negative because that would be imaginary. You can't have a fourth root. Because again, in 4, because if you have -1, put them together, if it's a fourth root, I would have 4 of them to come out of there. So negative times negative is a positive, times negative is a positive, is a negative, times another negative makes positive again. So we cannot have a fourth root or any even number roots. N cannot be any even numbers. That's going to give me imaginary numbers.
Okay, I just lost.
Okay.
Um,
N cannot be
even. It cannot be even.
it could be even, right? What can you not have in an even root?
A negative.
You cannot have a negative inside a even root. You can have it in odd roots, but not even. Because that means that you're going to have a restriction on your domain. Whenever there is restrictions, there is discontinuity.
Wait, what about the odd one? So if there's an odd.
Can I have a negative in an odd? Say yes.
Yes.
Because I need, in an odd root, I need 3 of a kind to actually make a whole. So this would give me -2. But if I do a square root, or fourth root, just to make life easier, okay, I'll get imaginary numbers there. Can't do that though. Imaginary. So that's restrictions again. Now, this one right here, using a power, okay, as I could just plug this in, that's going to be 2 to the 5th, which gives me 32. Okay, next one. And I can plug that one in too. So 2, right? So it's 2 times 1 minus 3 to the 3rd power. That's going to be 2 minus 3 is negative 1. Negative 1 to the 3rd power is negative 1. Did I lose anyone on that one? Limit as, okay, n is a positive integer. Okay, positive, that's a good thing. Integer, okay, that means it's going to start at 2 and go up from there. And so as x approaches c, my limit would be, I'm just going to replace the x with c. So that's going to be c raised to the n power. So you're going to get a lot of problems like this which actually don't have numbers that you're going to have to expand with whatever it is. All right, so this one right here is odd. Is there any restrictions here? It's an odd root. Is there a restriction?
Yeah.
No,
Oh, wait.
it's not. No restriction on odd roots. So can we plug in 4? Let's
Yeah.
try it. So it's 3 raised to the 4 squared plus 11. 4 squared is 16 plus 11 is 27. Cube root of 27 is 3. Trying to get to the factoring ones, but it doesn't look like I'm going to until next week. Fractional powers. Okay, I think we talked about this before, the fractional powers. Okay, so whatever my function is, it's going to be raised to power over root. So whenever you have something being raised to a fractional power, okay, like 2/3 or something, power over root. So the top would just be an exponent as a regular power. The bottom is going to be a root of whatever the root is. So if this was, let's see, let's just say f of x. That would be basically saying the 3rd root of f of x squared. So here's another example of
Could you go
this.
back?
Yeah. So I'm going to stop here. I'll pick up the rest of this on Tuesday.
Then we do this one again.
Yes,
All right.
as much as you can. Now, if you have never had a textbook before, scroll to all the way to the back. All the way to the back.
To the glossary?
And you will find in the back,
The answer to
there is an answer key.
it? Okay.
So answer, and it goes by section. We're doing 5, 4, 2. We gotta get to 1. 1, 2. There it is. 1.2. Did you find it? What page is that on? AN6. AN6. If you find that one. Okay, answer key's there. I want you to check your answer. I want you to show your work. I want you to check your answer. And if you cannot mathematically get that same answer, bring it back to me on Tuesday, and then we can work on it. That's what I want you guys to do. Okay? Try your best, do as much as you can, and we will continue these notes on Tuesday. Make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my merch store.